Hello everyone, this is Saida Javeria. Today's topic is about image enhancement in digital image processing. In this video, we are going to know about the introduction, the aim of the image enhancement, what is image enhancement and its techniques, examples, spatial domain enhancement, methods, conversion methods, required resources, experimental results, and application of enhancement techniques. An image defined in the real world is considered to be a function of two real variables. For example, a of x, y, with as the amplitude example brightness of the image at the real coordinate position x, y. Image processing is the study of any algorithm that takes an image as input and returns an image as output. It includes the following: image display and printing, image editing and manipulation, image enhancement, feature detection, image compression. The aim of image enhancement is to improve the visual appearance of an image or to provide a better transform representation for future automated image processing. Many images like medical images, satellite images, aerial images, and real life photographs suffer from poor contrast and noise. It is necessary to enhance the contrast and remove the noise to increase quality. Enhancement techniques which improves the quality, clarity of images for human viewing, removing blurring and noise. Increasing contrast and revealing details are examples of enhancement operations. What is image enhancement? Image enhancement process consists of a collection of techniques seeking to improve the visual appearance of an image or to convert the image to a form better suited for analysis by a human or a machine. The principal objective of image enhancement is to modify attributes of an image to make it more suitable for a given task and a specific observer. The diagram shows where an image is given as the input and the enhancement technique is applied and the better image comes as an output. Image enhancement techniques. The existing techniques of image enhancement can be classified into two categories: spatial domain enhancement and frequency domain enhancement. Image enhancement requires point operation, spatial operation, transform operation, and pseudo coloring. The examples of image enhancement techniques are shown, where the first is noise removal and the second one is contrast adjustment. The three contrasts are low contrast, original contrast, and high contrast. Spatial domain enhancement. Spatial domain techniques are performed to the image plane itself, and they are based on direct manipulation of pixels in an image. The operation can be formulated as g of x, y is equal to capital T of f of x, y, where g is the output, f is the input image, and t is an operation on f defined over some neighborhood of x, y. According to the operations on the image pixels, it can be further divided into two categories: point operations and spatial operations, in which including linear and nonlinear operations. The enhancement methods. Contrast stretching. Low contrast images can result from poor illumination, lack of dynamic range in the image sensor, or even wrong setting of a lens aperture. The idea behind contrast stretching is to increase the dynamic range of the gray levels in the image being processed. The general form is S equals to 1 divided by 1 plus m by r whole power e, where r are the input image values, s are the output image values, m is the threshold value, and e is the slope. Figure shows the effect of the variable e. If E equals to 1, the stretching became a threshold transformation. If E greater than 1, the transformation is defined by the curve which is smoother. And when E less than 1, the transformation makes the negative and also stretching. Noise reduction. This is accomplished by averaging and median filtering. These are as follows. Median filtering. The median filter is normally used to reduce noise in an image by preserving useful detail in the image. The median filter considers each pixel in the image in turn and looks at its nearby neighbors to decide whether or not it is representative of its surroundings. The median is calculated by first sorting all the pixel values from the surrounding neighborhood into numerical order and then replacing the pixel being considered with the middle pixel value. Here is an example. The neighborhood values of matrix are 115, 119, 120, 123, 124, 125, 126, 127 and 150. The median value is 124. The noise removal using averaging. Image averaging works on the assumption that the noise in your image is truly random. This way, random fluctuations above and below actual image data will gradually even out as one averages more and more images. Median filtering. This kind of noise are called salt and pepper noise. If we apply smooth filtering, we can't remove the noise. The median filtering steps are as follows. Arrange a 3 cross 3 empty mask. Intensity adjustment. Intensity adjustment is a technique for mapping an image intensity values to a new range. That is J is equals to image adjust I comma low in high in comma low out and high out. Histogram equalization. Histogram equalization is a technique that generates a gray map which changes the histogram of an image and redistributing all pixel values to be as close as to a user. It allows for areas of lower local contrast to gain a higher contrast. Use of histogram equalization. Is used for manipulating contrast, increasing the brightness. Histogram can control the image quality. The quality of image is normalized and then histogram for flat profile. To get a high quality image, the histogram should be normalized to be a flat profile. The example of a histogram equalization is shown. Image thresholding. Thresholding is the simplest segmentation method. The pixels are partitioned depending on their intensity value T. Global thresholding using an appropriate threshold T. G of x comma y is equal if g of x comma y is equal to 1 if f of x comma y greater than t. It is 0 if f of x comma y less than equal to t. Image a poker, Imagine a poker playing robot that needs to visually interpret the cards in its hand. The example is shown. Thresholding. Objective is to partitioning images directly into regions based on intensity values and or properties of these values. Gray level slicing. Gray level slicing is a spatial domain equivalent to band mask filtering. A gray level slicing function can either emphasize a group of intensities and diminish all other, or it can emphasize a group of gray levels and leave the rest alone. The figure above shows an example of gray level slicing with and without background. Image rotation. Image rotation in the digital domain is a form of resampling but is performed on non-integer points. The equation below gives the coordinate transformation in terms of rotation of the coordinate axis. Sx is equals to dx cos theta plus dy sin theta. Xy is equal to minus dx sin theta plus dy cos theta. Conversion methods. Grayscale conversion. Conversion of color image into a grayscale image inclusive of silent features is a complicated process. The converted grayscale image may lose contrast, sharpness, shadow, and structure of the color image. To preserve these silent features, the color image is converted into grayscale image using these algorithms as stated. The lightness method average the most prominent and least prominent colors. The average method simply averages the values. The luminosity method is more sophisticated version of the average method. The formula of luminosity is 0.21 R plus 0.71 G plus 0.07 B. The example of sunflower image are as follows. The original image is shown, the lightness is decreased, and the average image and the luminosity. The weighted average. This is a grayscale conversion algorithm that OpenCVs. Y is equals to 0.299 into R plus 0.587 into G plus 0.114 into B. The average method. It is the most simple one. You just have to take the average of three colors since it is an RGB image, so it means that you have to add R with G with B and then divide it by 3 to get your desired grayscale image. The luminosity method. The method is more sophisticated version of the average method. It also averages the values, but it forms a weighted average to account for human perception. Z is equal to 0.2126 into R plus 0.7152 G plus 0.0722 B. According to this equation, red has contributed 21%, green has contributed 72%, which is greater in all three colors, and blue has contributed 7%. Image file format. The file format is critical to the preservation of an image. The TIFF file, tagged image file format, is the current preservation format because it holds all the preservation information required to create a digital master of the original. Some of the file formats are TIFF preferred archival format, JPEG irreversible image compression, DNG universal camera raw format, etc. The resources required are software requirements, Windows operating system XP and above, MATLAB 7.10.0 RT2010A. Hardware requirements, hard disk 16 GB and above, RAM 1 GB and above, and processor dual core and above. Application of image enhancement are: it is used in biology, astronomy, medicines, security biometrics, satellite imagery, personal imagery. Conclusion. The material presented is representative of a spatial domain technique commonly used in practice for image enhancement. This area of image processing is a dynamic field and new technique and applications are reported routinely in professional literature and in new product announcement. In addition to enhancement, this serves the purpose of introducing a number of concepts such as intensity adjustment, contrast stretching, noise filtering, etc. that will be useful in various fields. And this is the end of the video, and thank you for watching.